Hello everyone, welcome to day 2 of learning Web3. So, in previous video, we learned what is Solidity, what is its use case, how do you write contracts in it, and a pretty simple syntax and how things work in Solidity. Today, we are going to learn what is Foundry and how to make more optimized code in Solidity for making a good smart contract. So, before we get started, I want to wait. Before we get started, I want to mention a very special guy who is kind of my mentor in this journey, and his name is Hark Solanki. Some of you guys might know him already. This is the guy. Wait, yeah, this is the guy. So yeah, he has made his own series on YouTube, which you can go and check out later. He has made tutorials for how to make smart contracts on Solidity, how to make a whole decentralized application like whole smart contracts, front end, back end. Okay, so yeah, do check that out later. So let's come to what did we learn today. Okay, so we learned about Foundry. What Foundry is? Foundry is a framework for Ethereum development. So if I wanna write, test, run, and modify my smart contract in my own local system. Previously, what we did, we used Remix IDE to write and test our code. Today, what regular developers use is this Foundry framework to, there are more frameworks also, Hardhat and other which are there in the market. We have learned this Foundry one. It lets you write, test, and modify your code. It's solid. So yeah, it provides four major tools. We can go through them one by one. The first is Forge. What Forge lets you do is it lets you build, test, debug, deploy, and verify smart contracts. Now, what it's pretty understandable. What Anvil does is Anvil is a tool which lets you run a local Ethereum development node with forking capabilities. Now, what it actually does is Anvil lets you create your own Ethereum blockchain node on your local system, on your own laptop or PC, so that you can deploy your smart contract over there and test it. Now, there's this tool called Cast. Now, what Cast do is it lets you interact with contracts, send transaction, and retrieve chain data. What does it mean? Whatever function that you write in your smart contract, you will be able to interact with it. You will be able to call that functions. So basically, what Force does is it lets you build, test, and deploy your smart contract on the blockchain environment, which is created on your local system, which is done by Anvil, and Cast lets you interact with that contract. Okay, this is the umbrella idea of what Foundry does. Now let's get to our contract that we made today. It's called a bank contract, which is a pretty basic but useful contract for understanding how transactions are made, how we have to complete the state of our contract, and some more optimizations in Solidity code. So yeah, there are basically three main functions of this bank contract. You can deposit, you can withdraw some amount, and you can get the balance of that particular account. So what does it do? If I try to explain it to you, that this deposit function has a check that if the amount that you're trying to deposit, if it is zero, so it just gives the the amount cannot be zero. So yeah, it will revert the error which is initialized over here, which is amount cannot be zero. Okay. And there's another check that if the message not value is not equal to amount, that the message not value means the transaction that is being made on that node. If the value in it, so like the price of transaction that is being made is not equal to the amount which is given to this parameter, then it will revert an error which is amount mismatch. So the amount doesn't match. If all these checks passes, then we'll just update the balance of that particular message or sender, which is the account which is trying to deposit the amount. It will be updated. So yeah, and it will emit that event key. Okay, the deposit has been successful. So it goes with the withdraw. We have this check which checks that if a person is trying to withdraw some amount of money from his account, then he or she should have at least that amount of money is in his balance. So yeah, if there's not enough balance to withdraw, then it will revert an error. Oh, there's insufficient balance. So yeah, and if it passes, it will say, oh yeah, just detect the amount of money or the amount of Ethereum from this account. So yeah, and then we check that, okay, is the transaction actually successful? If it is successful, okay. If it's not successful, then it will revert an error that, oh, the transaction has been failed, and it will return us an error. Else, it will emit the event, okay, the return has been successful. Then this basic function that lets you check your balance. Yeah, it just returns the amount of balance that particular account holds. Now, what we specifically learned today is that this public keyword specifies that this contract, once it gets deployed on the blockchain, that it can be accessed by anyone. So like anyone can view it, anyone can see कि उसमें क्या है, and anyone can call these function that we have made. So yeah, but it can be modified. It can be modified. This is the main functionality of the blockchain. There's nothing can be modified. And this what view does is that it specifies that only this function, this particular function get balance, can only be viewed. Is a read-only function. It will only return a value. You can't change the state of the contract. So yeah, let's try to run it using Foundry. Okay. For that we will need Unix-based operating system in your device. If you have a Windows, you can use Git Bash or WSL, which gives you the platform to run Unix on. Okay. So first we'll use Anvil. Now what Anvil does is Anvil will create the development environment in our own system. So what does it give us? It gives us 10 different kind of accounts with its public key and private key. Okay. And these are some sample data. This does not exist in real blockchain. These are sample data. So yeah, this is the URL that we have given. Let's just cross check. So yeah, this is the .env file that you have to create so that these values can be used while performing the action function and calling the functions. Okay, so let me just check something. Yeah, it's same. Now let's try to interact with it. We'll have to get another console over here. So wait, is this? Oh shit! No, we have to do it in this particular directory. So let me get into it, and now I should. It will be same, I think. No? Yeah, the URL is same. Okay, it's fine. Now we'll get into this console. Now we'll try to build our smart contract in that particular blockchain that we have created on our own system. First, we have to go in that directory and this, and yeah. Also, we have to get that .env file so that we can use these values. There is a typo. Yeah. Now we have these env files, env parameters. Now, first we have to build. Yeah, first we have to build our contract on. Now, what build means that we have to compile our Solidity code. So for doing that, we just write for build. I guess. Yeah, it's been compiled. Now, what we'll do is that I have the commands. The commands for this testing and calling functions are pretty big, so I have written it somewhere. I'll just copy and paste it. I'll explain what it does and how I be working. Okay, this is the command to deploy our smart contract. First, we compile the. Okay, we'll go first one, and we'll create the blockchain environment in our system to interact with it. Now, then what we did, forge build. Forge build actually compiled the Solidity code. Now we deploy that smart contract onto the blockchain that we have created using Anvil. So there's this command. It specifies what file do we have to select and what contract does it have, and which private key will it be deployed by. So private key here means who is the person is deploying this contract on the blockchain. So that will be specified over here, and this is the URL that you have to specify, that which URL will accept this request and will broadcast. Accept it. We have an error. What error do we have? Yeah, there's a pretty famous error that there's a little space over here which is not visible to us. That's why it's giving us this form of error. I'll just go ahead and fix it really quickly. We just have to, for that we have to just give that URL manually instead of using this RPC URL. It comes only on this command line. I don't know why, but let's just go into this. Okay, the smart contract has been deployed on the blockchain, and it gives us something that who is the deployer of this contract and where is it deployed. This is basically the private key of the smart contract, and this is the transaction hash. Yeah, to deploy this contract, there has been a transaction that has been made, and this is the hash of it. You can use it and track the transaction. Now, let's try our code. Okay, let's try our contract. First, we'll try to deposit some amount into any specific account. So we have this depositor account which I have took from here. All the data are pre पहले से भरे होते हैं हर बार ये सब एड्रेस वगैरह सब सेव रहते हैं. So yeah, there's this account that I have used as depositor over here. Now can I explain you what this particular command line is? It says cast, we पहले हमने देखा था कास्ट क्या करता है, इंटरैक्ट करने देता है हमें कॉन्ट्रैक्ट पे फंक्शन कॉल करने देता है. So yeah, it's saying that send a transaction to this URL with the private key. So it defines who is making this transaction. So we'll say okay, this depositor of this private key will make transaction of value. क्या होगा transaction में? It will contain 5 ether. We are making a transaction of 5 ether. Where to the contract that is being deployed, okay, and we'll call this function, which is called the deposit function, with the parameter with the argument as 5 this way. Now what is way? I try to explain it. As we have rupees and paisa, so that 100 paisa is equal to 1 rupee. In Ethereum we have ether, way and way. So 1 ether is equal to this much amount of way. So if I want to send 5 ether, then I'll have to say that okay, this is this much amount of weight. So 5 ether, 5 is this amount of weight. So let's go and try to send this transaction. Okay, this transaction has been made. I know there's a lot of jargon out here. There's a lot of data that is pretty useful if we are going in advanced decentralization. But right now, all we have to focus is what change did it make. Okay, what change did it make? So let's try to get the balance of that user and just deposit in this money. So yeah, to call the getBalance function, we'll call that function on this contract of this function name with the parameter. What we need is the address. Whose address? The person who's trying to get his balance. Okay? This is the private key. Not private key, it's actually the public key. Now where is it? This is being taken from here. Okay? This is the private key. Okay. So yeah, this person is trying to get his balance and from this URL. And actually we don't need this. Let's just remove it. If I call this, we'll have okay, this guy has 5 ether. So oh damn, that's good. I deposited 5 ether and my balance is 5 ether. Damn, that's good. If I try to deposit 5 more ether and then check my balance again, then I have 10 ether. So that's good. That's how this works. Same goes with the withdraw function. It will give some amount of ether from this wallet. I don't think I had to show that. So yeah, that's what we learned today. So we learned what is Foundry. Foundry is basically a framework for Ethereum development. It lets us write, build, test, and deploy our contracts on the blockchain. And what are its use cases? What tools does it provide? And how we can use it to make a good smart contract which can be deployed on a blockchain. Okay. So yeah, that's what we learned today. Tomorrow we'll continue with this series that I mentioned earlier. Do check it out. At last of the series, this guy has made a whole decentralized application. I think he is his partner with this series. Okay. So these two guys have made a decentralized application in the last 5 years of the series. So yeah, stick with me to complete this series and I hope you enjoy.